Okay, gentlemen, you are part of an experiment here to see if SGI would go a little bit better on camera. So what we'll do right now, you should have done your do now. We'll go ahead and I will quickly review. So I'm looking here at my pen at 4 p.m. The temperature in Toronto, Canada is 3 degrees Celsius. The temperature is scheduled to drop 5 degrees per hour. Well, we don't schedule temperatures, but it is predicted, okay? What will happen? What will the temperature be at 9 p.m.? So I'm going to go look at what would the temperature be at 9 p.m. All right, so let me go back and read this again. So at 4 p.m., it's 3 degrees Celsius. That's my start, okay? And we think it's going to drop 5 degrees per hour, okay? So that's going to go minus 5 degrees per hour, and we'll say H is the hour. So what will the temperature be at 9? So I need to find the difference between 4 p.m. and 9 p.m. So that's 5 hours, okay? So I'm at, excuse me. I'm going to start here. I like doing a vertical number line. If you did a horizontal number line, that's fine. All right. So this will be my 0, and I'm at 3 degrees, okay? And I'm going to drop 5 degrees per hour. All right, so that's my sort of change here, and I'm going to land here on this new temperature. Okay, so this is minus 5 degrees per hour. Okay, so 5 degrees times 5 hours means my temperature is going to drop 25 degrees. So minus 25 degrees. Okay, so here I have a 3. I'm going to subtract 25 degrees, and I know that I'm going to end up with a negative number because the absolute value of my negative in this case is negative. So I'm going to land on negative 22 degrees Celsius. So you should have picked B. If you did not, please take 30 seconds right now to update your notes to make sure that they look like mine. Let's take a look at number 2. Jemiah's bank statement shows a deduction of $1.50 taken out of her account each week. So taken out, I'm going to include that here because taken out means that's going to be minus 150 each week. How many weeks before the total deduction is $12? Okay, so in this case, I'm saying how many times do I take away this 150 until I get to a deduction, okay, which is also a negative of $12, okay? So I have my total that I'm looking for, which is negative 12, okay, divided by the amount of money each week, which is going to be negative 150, all right, and that's going to give me the number of weeks, okay, which is what I do not know. So what I'm going to do is I'm going to go over here and I'm going to say 12 divided by 1.5. All right, so I'm doing this as a review of how to do division with a decimal. I move the decimal point over here 1 so that it's 15. And then if I have my sort of imaginary decimal point, I move that over and add a 0. So what I'm actually doing is 15 going into 120, okay? And when I do that, 15 goes into 120 exactly 8 times. 8 times 15 is 120. So the answer is it will take 8 weeks. If you do not have that, please take 30 seconds now to fix your work. Okay, we are going to move on to mini lesson. So let's take a look here. Isabel is cutting wood to make garden markers. For each garden marker that is made, the length of the piece of wood changes by negative 0.8 feet. The length of the wood changes by a total of negative 4 4/5 feet after Isabel cuts all the garden markers. How many garden markers did Isabel make? Okay, so now that I've read that once, there's a lot going on here, all right? So I'm going to go back and read it again. Isabel is cutting wood to make garden markers. For each garden marker that is made, the length of the piece of wood changes by negative, right, 0 feet. So this is a decrease in size, all right? The length of the wood changes by a total of negative 4.5 feet, so that's my total change. How many garden markers did Isabel make? All right, so my key here, okay, so it tells me that the total change is equal to negative 4 4/5 feet. All right, and then I also know, excuse me, that each time she makes a garden marker, it's taking off 0.8 feet. All right, and so what I'm looking for is the number of garden markers. Okay, so I have a decision to make, and my decision is what calculation do I use, okay? And so in this case, I am going to use division. So I'm going to do my total divided by my sort of rate of change. So that's going to be the number of garden markers, the length of the garden markers is going to be equal to the number of garden markers, okay? So the other decision I need to make is, because I have a fraction and a decimal, do I want to work with fractions or do I want to work with decimals? In this case, I want to work with fractions because I don't feel like turning a mixed number into a decimal. Actually, I could easily do that. I could just do 4.8 divided by negative 0.8. But in this case, let's do it into a fraction. Negative 4 4/5 divided by negative 4/5. Okay, it's also easier to divide fractions. Okay, so I'm going to leave it. 5 times 4 is 20 plus 4. So I'm going to go negative 24, change that into an improper fraction, leave it, change it to a multiplication, and I'm going to flip my 4/5 and do 5 over 4. All right, so I always think when I'm doing division, leave it, change it, flip it, okay? So I'm going to do, excuse me, negative, excuse me, negative 24 times negative 5. Times negative, there. Okay, and that is going to give me positive 120. So I have 120, and then I do 5 times 4, which is 20. And so when I do 120 divided by 20, I'm going to get 6. She makes 6 garden markers. Please take 45 seconds, and if you do not have my notes, please put them there. You can hear my little guy crying in the background. We're almost done. Okay, let's take a look at number 2. A helium balloon on a string is tethered to a fence outside of a house. The altitude of the balloon can be represented by the rational number 12 1/4 feet. So altitude, by the way, height, right? That's how high it is. The string breaks and the balloon ascends 20 feet per minute for 5 minutes, all right? So that means ascends means it goes up. The helium then begins to leak out of the balloon, causing it to descend at 3.5 feet per minute for 4 minutes. Okay, so that means it's going to start to go down. What is the elevation of the balloon after it descends for 4 minutes? Okay, so in my key information box, the first thing I'm going to kind of remind myself is that here I'm starting somewhere and then I go up and then I go down. Okay, and drawing that sort of helps me. All right, so, and how's that going to work? So I'm going to start here. I'm starting at 12 1/4 feet. All right, and I am first going up 20 feet per minute for 5 minutes. And then, let me move down here. I'm going to go down 3.5 feet per minute for 4 minutes. Okay. Woo, that's a lot. All right, so let me write this over here. I have my start, okay, plus my change, plus yet another change is going to equal to my end. All right, so my start here, I'm going to do decimals here because we did fractions before. So I'm going to do 12.25 plus 20 times 5 plus negative 3.5 times 4. It's going to equal my end. Okay, so when I do 20 times 5, I get 100. And when I do negative 3.5 times 4, I'm going to get 14. All right, so I'm going to get negative 14 plus negative 14. So I have 12.25 plus 100 plus negative 14. Okay, so excuse me, that's going to give me 112.25 plus negative 14, all right, which is basically saying minus 14. And I'm going to end at 98.25, okay, which means the elevation is 98.25 feet, okay? So, gentlemen, at this point, you do have a quick partner practice. And so what that will look like is we are working together for 3 minutes. At the end of that 3 minutes, you should go ahead and get started on your independent practice. So teachers, if you're playing this right now, go ahead and pause the video. And then when we come back from the partner practice, we'll go over this together. Elizabeth, Darius, and Christopher dive into an extremely deep pool. Elizabeth dives to a depth of negative 9.4 meters from the surface of the pool. Sorry, I read that wrong. Let me erase it. Ooh, erase it. Okay. So a depth of, come on, man. Okay. to a, I don't know why it's doing this. To a depth of negative 9/4 meters from the surface of the pool. Okay, which is like 2 1/4 meters. Okay. Darius's depth is twice as far from the surface as Elizabeth's dives. Christopher's depth is, and of course I covered the thing so I can't read it, 2/3 the depth of Elizabeth's dive. What are Darius and Christopher's depths relative to the surface of the pool? Okay, cool. So in this problem, my key here, Elizabeth, she goes negative 9/4 meters. Darius, he goes 2 times that. And Christopher, he goes 2/3 of that. Okay. By the way, when you dive into a pool of water, there is a limit to how deep you can go. Just the human body just won't go a certain depth without being aided by like a weight or something. So Darius's depth is not something you'll ever see happen when diving, which is why like you never need a pool more than like 12 feet deep to do a dive. Okay. So let's first do Darius, okay? So I'm going to go 2, let's just say Darius here, 2 times negative 9/4. All right, so that's going to, I'll just change that into 2/1 minus, 2/1 times negative 9/4. 2 times 9 is 18. Okay, and then 1 times 4 is 4. 4 will go into 18. 4 and 2/4 time, or 4 1/2. Okay, so Darius is at negative 4 1/2 meters. All right, let's talk about Christopher. Christopher, he is 2/3 times negative 9/4. All right, and it's going to give me negative 18 over 3 times 4 is 12. Okay, so if I convert that, that's going to go negative 2. Give me here. Erase this. Negative 2 and 6/12, or negative 2 1/2. Okay, So Christopher's depth is -2 1/2. Let's see. All right. Do not forget your units. Okay, gentlemen, at this point, you are moving on to independent practice. Good luck, and I will see you soon. Bye.